In this video, we're going to examine the physical and chemical changes of matter. So we know that matter does not always stay the same. You can have iron and it can rust, water can evaporate, wood can rot, gasoline can combust or burn. So we're able to transform or change matter in two basic ways. Matter can undergo what we call physical changes, and matter can also undergo chemical changes. So in this video, we're going to look at these two types of changes. Let's start by examining how matter can undergo physical changes. In a physical change, you have the same type of matter, it's just in a different form or phase. So a physical change or physical transformation results in a different state or phase of the same substance. The chemical composition of the substance does not change. It only is converted into a different phase or state. The substance converts between a solid, liquid, or gas. So for example, water, if you have ice, of course that's the solid form of water, and if you melt that substance, you still have water, you still have two hydrogens bonded to one oxygen, but now it's in the liquid phase. So matter can undergo what we call phase changes, and there's a series of different types of phase changes that it can undergo. So for example, if you have the solid phase of matter, it can get converted into the liquid phase, and we call that melting, or the reverse process is called solidification or freezing. You can go from the liquid to the gas phase, and that is called evaporation. Or if a gas goes into the liquid phase, it's called condensation. Also, a gas can go directly into the solid phase, and that process is called deposition. Or a solid can go into the gas phase, and we call that sublimation. So be familiar with these terms that describe the different phase changes that matter can undergo. Now, physical properties of a pure substance characterize its physical state or physical behavior. So if you have a pure substance, each pure substance has its own unique set of physical properties. And the physical properties are often used to identify an unknown substance. So let me give you a few examples here of physical properties. Let's take water, for example, since we're familiar with that. Water has a certain set of physical properties. It has a certain melting point, which is 0 degrees Celsius. It boils, it has a certain boiling point, which is 100 degrees Celsius. It has no color, no odor, and no taste. Now, if you had a different substance, a pure substance like maybe methanol or something, or an alcohol, it would have a different melting point, boiling point. It may have no color, but it may have a different odor or taste. So each substance has a unique set of its physical properties, and we can use these to help us identify unknown substances. There's a lot of other physical properties, and here's a few of them. So you want to just kind of look over them. For example, each substance has its own unique density. Things have their unique texture, electrical conductance, and various things like that. Now, as we mentioned, matter can undergo physical changes, but matter can also undergo what we call chemical changes. A chemical change, during a chemical change, matter is converted into a new type of matter. It's converted into a new substance. So when a pure substance undergoes a chemical change or a chemical transformation, a different substance is formed. A chemical change is also called a chemical reaction. Some examples of this. If you have a piece of iron, it can react with oxygen to form rust, also called iron 3 oxide. Butane from a Bic lighter. Butane reacts or burns to form carbon dioxide and water. And silver, a piece of silver, can combine with sulfur in the air to tarnish. So in each of these examples, you start out with one substance, for example, iron, and it undergoes some change to form a brand new substance like rust. Of course, iron and rust have completely different physical properties, so we made a new substance. Butane, when you ignite it or react it with oxygen, you form carbon dioxide and water. Of course, carbon dioxide and water are completely different from butane, what you started with. So you start with one substance, undergo a chemical change, and you produce new substances with new physical and new chemical properties. And chemical properties are characteristics that determine how the composition of matter changes as a result of contact with other matter or influence of energy. So what does that mean? Well, basically, a chemical property is how that substance reacts with other substances. Characteristics that describe the chemical behavior of matter. So chemical properties are characteristics that describe the chemical behavior of matter. So for example, we mentioned that iron reacts with oxygen to form rust. However, gold does not react with oxygen to form rust. So a property of iron, a chemical property of iron, is that it reacts with oxygen from the air to form rust. Gold, a chemical property of it, is that it does not react with oxygen. Butane, we mentioned before that butane will burn to form carbon dioxide and water. If you try to burn water, water does not burn. So each of these substances has a unique set of chemical properties. Here's a few others. Some substances are very acidic. Some substances are very basic. So these are chemical property. Some substances are inert. In other words, they don't react very well. Some substances like sodium hydroxide is very caustic. It will react with your skin. And so basically a chemical property describes how that substance reacts with other substances. And finally, a chemical change, we can represent that with what we call a chemical equation. So let me give you an example. Let's say you had a piece of sodium metal, which is very reactive when it touches water, and you had chlorine gas. Chlorine gas is very toxic. If you combine sodium metal with chlorine gas, they react very explosively to form sodium chloride. And so this would be an example of a chemical change. We're starting with two substances, sodium metal and chlorine gas, and we're reacting those to form a brand new substance. So they undergo a chemical change. We could represent this chemical change or chemical reaction with a chemical equation. We could say sodium, Na, is the elemental symbol for sodium, and it's a solid. So we put a little S here for solid. So our sodium solid plus, that means it reacts with chlorine gas. Cl2 is the chemical symbol for chlorine, and it's a gas. So sodium solid plus chlorine gas react to form. The arrow indicates react to form, and the product here would be sodium chloride, which is a solid. So our chemical reaction, we have what we start with, we call those our reactants, and then we have what we produce are our products. So we'll talk a little bit more about chemical equations in another video. So be sure that you can distinguish between a chemical and a physical change, and be sure that you can discuss or describe what's happening during a physical or chemical change at the molecular or atomic level. Also, be sure that you can identify and understand the differences between chemical and physical properties.